we can use this information to make a battery. This is what you did last week in lab. Okay, so you made the Daniel cell. Here you have zinc, and here you have copper. Here you have your copper ion solution and your zinc ion solution. This thing here is your salt bridge. So let's see, we already labeled the zinc and the zinc ion. This is your copper and copper ion. Which one is the anode? Which one is the cathode? Which one is the positive electrode? Which one is the negative electrode? In which direction does the electron current flow? What is the half reaction of each electrode? And what's the overall cell reaction going to be? Okay, so I'll let you fill in those things on this diagram. Okay, so I think we talked about this lab. The cathode is the electrode at which oxidation occurs or reduction occurs. Okay, so the cathode is where reduction occurs. And then the anode is the electrode at which oxidation occurs. So, what's happening at the zinc electrode? Yeah, so zinc is being oxidized. So at the zinc electrode, okay, so we have our zinc. Okay, so zinc is being oxidized to zinc 2 plus. So this is an oxidation, which means that the zinc electrode, is it the anode or cathode? This is the anode. Okay, then this is hooked up to the copper electrode. And let's see, so at the copper electrode, what's happening there? Yes, we see a reduction reaction. So what's being reduced at the copper electrode? Yeah, so the copper 2 plus is being reduced to copper metal. And that means that the copper electrode is considered the cathode. Okay, let's see. So we did this. We figured out these 4 parts here. We looked at the half reaction. In what direction does the electron current flow? From the zinc to the copper or from the copper to the zinc? So it's going to go from the zinc to the copper. What is the overall reaction? Okay, so here's our 2 half reactions. So for our overall reaction, we can just add those 2 half reactions together. Okay, so let's see, we have zinc going to zinc, 2 plus 2 electrons. There's two electrons, there's copper. Okay, so we add these two together, and then you get your overall reaction. That's zinc plus copper 2 plus going to copper plus zinc 2 plus. This was the reaction we just looked at. And you put the zinc and the copper in solution. Okay, and then for the last part, which electrode is a positive one, which one is a negative one? So in a battery, there's a positive terminal and a negative one. So which one was a positive and negative? And then you confirmed this when you hooked up, when you recorded the voltage from your battery using the voltmeter. So when you hooked up the red lead to the zinc and the black one to the copper, did you get a positive voltage or a negative voltage? Okay, remember? The few of you showed this to me last week.
If you hooked up which ones?
Okay, so for example, if you hook the red lead to the zinc and the black lead to the copper, did you get a positive voltage or negative voltage?
Positive. Because the zinc is the positive, right?
Now that's what I'm asking you. You want to confirm this by doing the experiment.
Well, if it comes out negative, then the cables are bad.
So what did you get? So when you hooked up the red to the zinc and the black to the copper, did you get a positive voltage or negative voltage?
Positive.
Are you sure?
The zinc's the actually, no, because zinc's the anode. It would have been negative. It'd be negative because zinc's the
Black is
anode.
a negative.
Yeah. Negative. Yeah. So
Yeah, so red is a positive, black is a negative.
negative number. Because zinc's the anode, right? And copper's the
No, all I'm asking is that when you hooked up the red to the zinc and black to the copper, did you get a positive voltage or negative voltage? That's the question.
Negative.
Okay, so that means that when you hook up the red to the copper and the black to the zinc, you should get a positive voltage, which means that the positive electrode, based on that observation from the lab, the positive electrode should be
Copper.
yeah, so this should be the positive, and this should be the negative. Okay, so what this is telling us is that although the zinc is losing electrons, that's going to be the source of the electrons. Therefore, this is the negative terminal from the battery. Okay, so get negative terminal from the battery. This is the source of electrons. I think we might have said it was the reverse last time in lab. Okay, I think we said that last time in lab this was the positive because it was losing electrons. That was negative because it was gaining electrons. But it turns out that since you saw from the lab that this was the negative terminal and this is the positive terminal according to the voltmeter, that means that the zinc, although it's losing electrons, this is going to be the source of electrons. Therefore, this is the negative terminal or the negative electrode. Okay, so the source of electrons is going to be your negative electrode. Okay, so let's see, if you want to take a look at a zinc copper cell animation, there's a website we can take a look at that. If you want to learn more about salt bridges, here's another link. We can learn more about salt bridges. Now we also figured how much voltage the zinc copper battery produces, and the way we can do that is by looking up the standard reduction potentials, and I hope I got these numbers right because I was doing this last night without a book. I was hoping that after doing this many times I would remember what the numbers are. So let's see, from table 19.1 from the textbook, that's on page 670, let's see. So what you want to do is look up there's two methods. We want to look at the standard reduction potentials for the two reactions. So we know that copper 2 plus is being reduced. So when we look that up, did they get that right as plus 0.34 volts. Let's see. I hope so. Yeah, so copper 2 plus going to copper is plus 0.34 volts. Note that the other one we're going to look up is a zinc 2 plus 2 electrons going to zinc. Note that zinc 2 plus is being reduced. In this table, all they're doing is showing the reduction half reactions for they're not showing any oxidation, only reductions. Okay, so for the zinc, it's minus 0.76 volts. So there's two methods. This is the method from the book. They're saying that the cell voltage is equal to the E cathode minus the E anode. The cathode, as we said, is the reduction reaction. The anode is the oxidation. So that'll be plus 0.34 volts minus a minus 0.76 volts. Note that the minus 0.76 volts is the reduction potential for the reaction which occurs at the anode. So plus 0.34 minus 0.76 is plus 1.1 volts. The other way to do this is to take the oxidation reaction, which is this one, zinc going to zinc 2 plus 2 electrodes. And note that this is the reverse of the reduction half reaction. Okay, so all you do is just change the sign from minus 0.76 volts to plus 0.76 volts. And then you can just add the reduction plus the oxidation. That gives us the same answer, plus 1.1 volts. So when you did this in lab last week, you got close to 1.1 volts. The closest I saw was like 1.08 volts. Was the voltage you measured in the lab last week. Also, electrochemistry is an application of thermodynamics. So here's another equation that the cell voltage E is proportional to delta G by this equation. So delta G is equal to minus N, which is the number of moles electrons transferred, times F, which is Faraday's constant, which is 96,500 coulombs per mole, where a coulomb is a unit of charge, and then times G. So note that if E for a battery is positive, that means delta G should be positive or negative? Negative. Okay, so for a battery, when you do this calculation, E should be a positive number, because this reaction should be spontaneous, because delta G should be less than 0. Okay, so you ready to move on? Not yet?
1 minute. 1 minute to stop on the clock.
Bruce?
What's the E?
E on this equation?
Yeah.
E is E cell. Actually, you know, you could use, this could be a reduction potential or oxidation potential. You can plug in any E if you want to. So again, note that if E is positive, delta G is negative. Okay, so for any battery, E cell should be a positive voltage. And note that in a battery, we're converting what type of energy to what type of energy?
Chemical to energy.
Yeah, so we're converting, like Bruce says, chemical energy to electrical energy. Okay, so I'll post, I worked on this slide last night, so I'll post this slide this afternoon. So you guys can take it. Okay. Okay, so we just answered. So for battery, E cell should be positive. I think you did this in lab too. You're given 5 metals, aluminum, copper, zinc, iron, and silver, and their corresponding metal ion solutions. Now, which 2 metals would you use to make a battery with the highest voltage? Would you use the best reducing agent and the best oxidizing agent? The most active metal and the least active metal? Would you do it by trial and error, or would you just buy a battery with the voltage you need at the store? Yeah, just buy a battery.
Just buy a battery.
This is actually an exam question. You're lost somewhere, or your car is out of gas and the lights just went out in your house. You have a few metals. All your batteries are dead, so you got a couple metals lying around the house with some metal ion solutions. So It's never happened to you guys? So you have some metal iron solution floating around your house, so you figure, God, what do I gotta put together just to get the radio on so I can see when the power gets in my house and come back on. So I can run the dishwasher and watch the news on TV and do all those things before you go to sleep. Okay, so how are you going to do that? So how are you going to figure out what metals to use?
Table 19.1.
Yeah, so like Rolando says, let's take a look at table 19.1. Now, let's compare table 19.1 to the activity series of metals. Now, in the activity series, this was figure 4.14, I think. This is figure 4.14 on page 117 in the textbook. So let's just record a few of these metals. Let's list these metals on from here. So aluminum, copper, zinc, iron, and silver. So let's see, the most active metal of those is aluminum.